Today we're going to continue with our slope-intercept form for the equation of a line. We're just going to make sure we really understand this form really well before we move on to a different type. So you should be able to do some of these things by now. You can find the equation of a line if I give you the graph in slope-intercept form. So if you want to find the equation in slope-intercept form, you are needing two parameters. You're needing m, which is the slope, that becomes a coefficient of x, and you will need b, the y-intercept, and you plug them into your slope-intercept form. M and b are the two parameters. X and y are your variables. They are the input-output for your rule. M and b are the parameters that create your rule, your multiplication parameter and your addition or subtraction parameter. So in this case, my y-intercept is 2, and my slope is, find two clear points, my slope is 2 over 4, which reduces down to 1 over 2, and since my line is falling left to right, my slope is negative 1/2. So I would plug that in. My negative 1/2 is my slope, and my y-intercept is positive 2. I now know the rule for every point on this line, how to get from x to y. When I plug in negative 2, I should get 3, etc. Over here, same thing. In this case, my y-intercept is negative 1, and my slope is, again, we have to count a rise over a run. So our run is going to be to the right 2, because we can see, I should draw it a little better, to the right 2 from 0 to 2, and the height is going down 3, and then one more is 4. So in this case, my slope is 4 over 2, which is 2. My slope is 2, and my y-intercept is negative 1. We should be able to find the equation of a line in slope-intercept form. If I just give you the slope and I give you the y-intercept, in this case, since it goes through the origin is that point right there, 0, 0. So my y-intercept would be 0. So my slope is 3, my origin is 0. I don't need to write plus 0, so that would be my equation, y equals 3x. If I give you the equation, you should be able to identify the slope in the y-intercept. So y equals x over 3 plus 2 is the same as y equals, if the x is in the numerator, you take the coefficient of the x in the numerator. So I could rewrite that as 1/3 x plus 2. So my slope is 1/3 and my y-intercept is 2. If it's not in y-intercept form, you should be able to rearrange it. You need to be able to isolate that y. So you're going to get negative y equals negative 5x. The 5x needs to cross over the equal sign. The 2 is already on the right, so it stays positive. But it's negative y, so that negative stays with the y. But now I need to divide everything by negative 1 to isolate the y, get a positive y, a negative divided by a negative. And so I get y equals 5x minus 2. Same thing over here. I'm going to isolate the negative 5y. I'm going to move the 4x to the other side. I'm going to move the negative 20 to the other side. And now I'm going to divide everything by negative 5. And so I get y equals 4 over 5x minus 4. My slope is 4/5, and my y-intercept is negative 4. You could graph using this as well now. I'm going to skip D. Well, let's do D quickly. I'm going to isolate the negative 6y. I'm going to divide both sides by negative 6. I'm going to get y equals 4 over 6. It has to be reduced. If it can be reduced, a negative divided by a negative is positive. So you always leave your slope in lowest terms. And so my slope is 2/3, and my y-intercept is plus 0 at the end. In other words, it's going to go through the origin. E and F are special cases because if you notice with E, there is no x. So if there's no x, you just isolate the variable. It's a constant function, right? Where my slope in this case is 0. Y equals negative 3. Y is negative 3 right here. That's a constant function with a slope of 0. Same thing here. You isolate the y, divide both sides by 2, Oh, y is negative 2. My constant function is where y is negative 2. And so my slope in both of these cases is 0. And in this case, my y-intercept is negative 3. And in this case, my y-intercept is negative 2. You should also be able to graph. So just like we did before, you need to identify your slope and you need to identify your y-intercept. And then to graph, you plot your y-intercept and you count out your slope. Your slope is a fraction. Down 2 over 1, down 2 over 1. And you do that quite a few times. Or you could go the opposite direction, up to left 1, because it's negative slope, it's falling left to right. The more you do, the more accurate you are. And then you create your line. And that is that line for that function. Let's try the next one. The next one would be, my slope is going to be, again, there's a negative. So my slope is going to be negative, and again there's no number up here, so it's a 1, negative 1 over 4. My y-intercept is 1. You plot your y-intercept first because that 0, 1 is 1 point on my line. It's one xy pair. We know that satisfies this equation. When I plug in 0 for x, I get 1 for y. And so now I use my slope, negative 1 over 4. Down 1 over 4. Down 1 over 4. Or I could go up 1 over 4. And then I draw my line through it. Let's draw. And we have our line. There you go. The next question you'll notice is not in slope-intercept form. So to be able to graph, we have to have it in slope-intercept form unless we want to make a table of values. But I like slope-intercept form if it works out nicely. So I move my 2x to the other side. I divide everything by 5. And now I have my y-intercept of 2. And I have my slope of negative 2 over 5. Again, the slope is negative. And I could count that a few times. And then I could graph this by creating my line, going through those 3 points. And there you go, how to graph a line using slope-intercept form. Sometimes we have constant functions, just like before when we had a constant function, something like y equals 6. Well, this is a slope of 0. This is where y is always 6. It doesn't change. There's no rate of change. This is where y is 6, if I've counted correctly, and so we just draw a line through where y is 6. And I would label that y equals 6. Sometimes instead our constant function could be for x, not necessarily y. X equals 4. So when we want to find out where x equals 4, we now go to x being 4. 1, 2, 3, 4. That's where x is 4. X is 4 along that entire line. In this case, it's a vertical line because all of these points have a x coordinate of 4. It is a constant function where x is not changing. My y is changing, but x isn't. In this function, my y is staying constant, but my x is changing. So whenever you have x equals, it is a vertical line. Whenever you have y equals, it is a horizontal line. So these families, y equals any number, is a horizontal line with slope 0. My x, where x is any number, those are just k's showing a variable. X is any number is a vertical line with undefined slope. Remember, all vertical lines have undefined slope. I could ask you maybe something a little bit trickier. I could say, can you find the equation of a line with the same slope as this function and the same y-intercept as this function? So you need to pull the appropriate information out of the function. So if you want the same slope, we first need to find the slope. So what is the slope of that function? So I have to put it into slope-intercept form to know this. So I write 3y equals negative x plus 9, divide everything by 3. I have y equals negative 1/3 x plus 3. I now know the slope is negative 1/3. If it has the same slope, my new function will have that. So it's y equals negative 1/3 x, and it has the same y-intercept as this. So now I need to know what is my y-intercept. So again, I'm going to put it into slope-intercept form so I can figure out what b is. So I'm going to get negative 2y equals negative 3x plus 24. Divide everything by negative 2. I'm out of room here. Divide everything by negative 2. Y equals 3 over 2x minus 12. Minus 12 is my y-intercept. So if it has the same y-intercept, I now know it's minus 12. And so there's an equation of a line with the same slope as that function and the same y-intercept as that function. I just needed to put it into slope-intercept form to be able to pull out the appropriate information. One thing we're going to learn new right now is about parallel lines and perpendicular lines. If we look at these three parallel lines, A, B, and C, what you'll notice is if parallel lines have the same slope, they never intersect if they are all changing, having the same rate of change, right? So if I go 1, 2, 3, up 4, and over 1, 2, 3, 4, 5, 6, or 2/3, or any proportion to that, all of these functions all have the same 2 as compared to 3, 2 as compared to 3 ratio, 2 as compared to 3 ratio. So parallel lines all have the same slope. Perpendicular lines, lines that intersect at a 90-degree angle or right angle, they obviously do not have the same slope. The one thing you do notice that is if one line is rising, the other line is falling. So we definitely know that the slopes are opposites. In other words, if one is positive, the other has to be negative. The other thing is to create a 90-degree angle. If we look at our slopes, for example, this red line has a slope of 4 over 3. The black line there has a slope of 3 over 4. To create a 90-degree angle, the rise is equal to the run, and the run is equal to the rise. In other words, the slope of 4 over 3, this one would be 3 over 4. We call those reciprocal slopes. So, perpendicular lines have reciprocal slopes and also opposite slopes. So the red line is negative, but the black line is a positive slope. We call these opposite reciprocals. You take the reciprocal slope and change the sign. For example, the slope of this red line is 1 as compared to 3. And since it's falling left to right, it's negative. The slope of the black line is going to be the reciprocal and positive. Let's check. The reciprocal and positive. Yes, it is. 3 over 1 is just the same as 3. I don't need to write it as 3 over 1. I can just say the slope is 3. So, we're going to use that as well today. So, remember, parallel lines have the same steepness. The slope of parallel lines are equal. Parallel lines, of course, have to have different y-intercepts, otherwise they are the exact same line. Perpendicular lines are opposite reciprocals. When you have opposite reciprocals and you multiply them, you'll notice whenever you multiply opposite reciprocals, 3 times negative 4, 4 times 3. You'll always get a product of negative 1. So whenever you multiply opposite reciprocals, you will always get a product of negative 1. A horizontal line is perpendicular to a vertical line. So if my slope was 0, my perpendicular slope would be undefined. Let's practice with that. So With a y-intercept, we're going to find the equation of a line that has a y-intercept 9 and is parallel to this equation. Well, if it's parallel to this equation, it has the same slope. And since this is in slope-intercept form, I know the slope. My slope is m right there. So I can create my equation by plugging in m, my slope of my line, and my y-intercept for b, plus 9. There's the equation of a line parallel to this one with a y-intercept of 9. If I want it going through the origin and perpendicular to this line, well, instead of using the -2/3 slope, I'm going to use the perpendicular slope. I'm going to take the opposite reciprocal slope, so I flip it and change the sign, and the origin is a y-intercept of 0. So I'm not going to write plus 0, I'm just going to leave it blank. So that is through the origin with the perpendicular slope. With the y-intercept -5 and parallel to this line. So y equals x has a slope of 1. My slope is the coefficient of x, which is 1. So my parallel line will have the same slope, so I'll use my 1x, I don't need to write the 1, and then I'm going to include the y-intercept of -5. With the y-intercept 2 and perpendicular. So if my slope is 1, then my perpendicular slope would be the reciprocal of 1 is 1, and the opposite reciprocal is -1. So my slope is going to be -1. So I'm going to write y equals, I'm not going to write -1x because I don't need the 1. I'm just going to write it as -x. Y is -x with a y-intercept of 2. With the same y-intercept as this equation and parallel to this equation. So if the same y-intercept is going to be, well, I know the y-intercept is going to be -1, so I know the y-intercept, and if it's parallel to this equation, it has the same slope. But I don't know the slope of this equation because it's not in slope-intercept form. So if it's ever not in slope-intercept form, I just have to put it into slope-intercept form to be able to calculate. So divide everything through by -5. And I'm going to get 3/5x plus 3. So I now know my slope is 3/5. So if it's the same slope, you'd use it. If it was perpendicular, you'd use -5/3. And I know my y-intercept. So now I can plug in. I can get y equals 3/5x minus 1. Last two questions here. It goes through -5, 3 and is parallel to the y-axis. The y-axis is a vertical line. So it's parallel to the y-axis and it goes through -5, 3. So let's find -5, 3. So -5, 3 is about there and it's parallel to the x-axis. So it's a vertical line. So if it's parallel to the y-axis. So it's cutting through the x-axis where x is -5. So that's the equation of my line. X is -5. It's wherever it's cutting through. It's cutting through the x-axis, it's where x is -5. If it goes through 1, -1, and it's perpendicular to the y-axis, well, this is the y-axis here, so perpendicular would go this way. So now we have a horizontal line and it's cutting through where y is -1. This is where y is -1. So that's the equation of my function, my constant function. Y is -1. Okay? So we talked about reviewing how to graph, how to name lines in slope-intercept form, and we also incorporated some parallel and perpendicular slopes with our slope-intercept form.